Hi, this is Joe with Vargus. We're here at Cutting Tool Engineering for another episode of Bourbon with the Editor. And this week we're going to have a technical talk about processing a part with Will from Vargus, Aaron from Harper College, and Dennis from Cutting Tool Engineering. So stay tuned and enjoy.
Thanks,
Cheers.
Joe.
Thanks, Joe.
Yep.
All right. Can you get back to there? All righty. So, yeah, let's get down to it. So, Aaron Kolb, Will Nash. We're we'll get around to that in a minute, because once I'm done introducing this bourbon, the show's going to be all you guys. So this is what we're drinking tonight. Is called a Horse Soldier. Let's see, is that on there? I can't tell. There we go. And that is got a nice little story. Nice. So the backstory on this bourbon is this. Right after 9/11 happened, 12 Green Beret were covertly inserted into Afghanistan on horseback. And they were charged with going in and taking control of the city of Mazar-e Sharif. Yeah, let's see. It's something like that. Yeah, Mazar-e Sharif. And they took it from the Taliban. And they got the nickname. They were successful in all that. I mean, there's been movies. They got the nickname the Horse Soldiers. And of those 12 Green Beret, 6 of them, I think it is, came back and decided to start the American Freedom Distillery in Columbus, Ohio, is where it is now, I believe. And they have come up with this bourbon in honor of their background, the Horse Soldier. And as the writing goes, the flavor is as bold as the story that brought it to us. So, cheers to them.
Cheers to them.
Cheers.
And that came from Smoky D&D Smoking Spirits right here in Arlington Heights. Just want to throw a shout out to Harry. He's the guy who got me to grab this bottle of bourbon. So.
Perfect.
So now we do have a bit to cover here because we're doing things a little bit differently. We went out to Harper a few weeks ago now, and a couple of weeks ago, to capture video of the whole process involved in how you go about machining a part.
Yep.
So I'm going to let Will and Aaron take over, and I'll just chime in with what I witnessed while I was there and ask any questions along the way. So
Perfect.
take
Great,
it away,
thank
Will.
you.
Well, I would start by introducing myself. I'm Will from Vargus. I think most anybody watching has seen me before, but I'm an applications engineer with approximately 15 years experience now in the cutting tool industry. We're here with Aaron, who I've recently met, become acquainted with, and done a couple of projects now. I think this is actually our second project that we've done together. And Aaron is from Harper College, and I'd like to give you an opportunity to introduce yourself and your program.
Great.
Yeah.
Great. So my name is Aaron Kolb, and I am a associate professor at Harper College of the Advanced Manufacturing Program and Welding and also Fabrication. So I've been there since January of 2016. Prior to that, I've worked in manufacturing industry for various companies, held various roles. And so now we have an associate's program. We start out with the manual machining, we have quality control, and then we have CNC programming, solid modeling, kind of all the standard classes, along with welding and fabrication classes as well. So I first met Will, and he came out to my class and talked to us about threading. We did some great demos for the students and showed them some real-world applications, and I was really happy to help out with this project, and kind of excited to do more, and not only to bring more, of these processes to light for Vargus, to help them out with their tools and to showcase what they can do, but also to hopefully bring some attention to the program and maybe get some more students interested, whether it kind of grows organically from the high schools, or maybe there's some manufacturers out there that would like to, kind of upskill their employees and kind of send them back to school for some classes that we offer.
Absolutely, and in that spirit, if people are interested, how can they get in touch with you or your program?
Yeah, so they can either contact Harper College directly at harpercollege.edu, and under there they can find the manufacturing program, or Harper does have a general number that anyone can call and then just ask for advanced manufacturing. They can also email me directly, and my email is kolb@harpercollege.edu, and I'm happy to answer any questions or any emails about the program or what we're doing here tonight. And those are probably the two best ways to either find out more information or about the program or Harper College in general.
Okay. I'm curious, I know I've seen your shop, but not everybody has. Approximately how many square foot have you got available?
So square footage, I think we have, with the two different labs, where we have a manual machining lab, and then where we have our fabrication, welding, and CNC, it's probably close to 17,000 square feet, I'm guessing.
Yeah, it's a pretty good sized
Yeah.
shop. And you guys have it pretty full of machines now too, right?
We're packed. We have 7. We have 11 CNC machines, and we recently added a 5-axis and a turning center with live tooling and a sub spindle. So that's pretty exciting. We don't have those quite online yet, but that's coming, and we're going to be teaching some automation with a cobot arm and a vertical mill, and just try to hit all the, provide some of the highlights of what is going on in manufacturing today, and how the field is advancing, and how these students can really have a rewarding and actually high-paying career path if they choose manufacturing. And it doesn't have to be directly machining or welding. It can be, manufacturing, as you know, is such a big umbrella of opportunity.
Yeah.
Whether it's, machine tool sales or setup, or, it could be cutting tool sales. I mean, there's, application engineering opportunities, and then, of course, management. There's just I always tell my students, if there's any kind of interest that you have, we can find a place for you in manufacturing.
Yeah, and I mean, I know firsthand. I go into shops all the time, and everybody wishes their engineers had had a program like this before they started doing design work. So, even for people who are thinking that they might like to go into some sort of engineering, this would be an excellent start.
And that's that was kind of my career path, kind of a vocational background where I started, similar to Harper, maybe a little more intense, but I thought it was the perfect stepping stone into an engineering program.
Yeah.
And I felt like I had such an advantage over my peers just knowing how things worked. So I couldn't agree more with, even if that's the path you want to take as far as engineering, this is a great place to start. And actually, Harper, we do have an articulation agreement with several colleges where they'll accept our associate's degree, and it ends up being a 2+2 kind of journey, where they'll take our degree, and then you complete 2 more years, and you can get like an engineering degree, more like an engineering management degree.
Okay.
And if you want to go into like a design or a mechanical engineering, you might have to take some leveling classes on the math side, but other than that, it's still a really good opportunity.
That's great. Yeah, there's a lot of programs out there that their credits don't transfer very well, and
Yeah.
a lot of times you don't find that out until you're done with your program. So
Yeah.
knowing that ahead of time is great.
And one of the universities is IIT in the city, which is a pretty well respected
Yeah.
engineering school. So
Yeah, absolutely. Well, that's awesome. Again, thank you for the use of your shop.
Yeah.
Very excited to talk about this tonight. I would like to mention that we're doing this series in 2 parts. So we did all of the lathe operations in part 1, and we're going to be doing the milling operations in a separate podcast. Okay? I think we have a print available of the part that we're making, and we'll get that up on the screen here momentarily, but we'd like to show you the part. Here it is. We got some MPT threads, some OD turning and grooving, and then we've got some internal work. So we're able to showcase a few of our different tools and some different operations on the lathe. This part, we picked it because it's reminiscent of an oil and gas industry sector part. So it's a part that a lot of people out there are either going to know about, or it's going to have features that a lot of different people are going to do. And normally for our process, right, it revolves around having a print, right? Normally the customer would supply a print and say, hey, this is the part that we need to make, or the feature on this part that we're having trouble with. But this was a little bit of a unique scenario. I didn't necessarily imagine that you had anything that you were having trouble with. You were probably already mastered everything that you did. So we said, okay, we'll come up with a print in order to do that.
And I gotta say, we purposely want to make this like it's one of the calls that you make
Yeah.
to customers. And I mean, yes, you're a customer, but this usually there'd be like NDA kind of stuff and privacy concerns about getting too detailed into something that one of your customers are making. So
Yeah, absolutely.
that's why this was really an ideal way to go about this.
Yeah, absolutely. Our customers work in aerospace and firearms and defense and things like that, and there would be no way we could share one of their prints. Yep.
Right.
So I forgot to give you the NDA.
Oh no, a little late now. Have another drink.
Yeah.
So for this part, for this pump shaft, we had a good lineup of tooling. If we can get the picture of the tooling table up on the screen, it's going to be slide number 2. We started out from, I think it's going to be on everybody's right. We brought some of our gauges to inspect the threads. We had a plug gauge and a ring gauge to inspect the internal and external threads. And then we had a threading insert, and I'll talk about the grade and the geometry a little bit later, threading bar and anvil, and we'll talk about setting the anvil, choosing the anvil a little bit later too. Then we had one of our microscope in the dog leg holder, so this kind of, it's the, well, I guess that's, the third one there from the right, is the microscope and the dog leg holder, and we chose this specifically because of the machine, right? There were some limitations with work holding being a tool room lathe. So this type of work holder would be typical of something we'd see on a Swiss machine, but again, it's also indicative of our ability to suggest tools and work holding in every possible situation. Then we use that same holder for the internal threading. We used our ST cut, which is like a dog bone style insert for the OD turning, and this is kind of an interesting tool. We'll talk again about this a little bit later. And then maybe hard to see here, but we have one of our center drills, and not shown in this image is one of our drills. So we'll get onto that just a little bit later. At Vargus, as an application engineer, I often need to do a lot of programming, right? We offer a full line of cutting tools, and we've decided to partner with hyperMILL from Open Mind Technology because this was a bigger project and because it was an opportunity for them to showcase their product a little bit, we decided to ask their application engineer to come in and program it. But if we could get on to the next slide, I will show you some of the things that I really like about it. So as a tooling guy, obviously the ability to set tooling, I really like it. The way that their tooling library is very easy for me to use. If we could get to the next slide again. The way that we assign cutting process and cutting parameters, very easy to use. And then one more slide. So here's the custom tool. So this was a completely custom tool that we used for the threading. It was actually a special tool for us because we wanted to do for the internal threading very small diameter, very deep thread. So we had a customer who was using some of these special tools, and we were able to get a couple of them from them to be able to showcase this thread. Very long reach here, and we were able to completely design this, the shank, the holder, and the cutting edge in hyperMILL in a matter of minutes. Very easy, again, for everybody, for us to set up. And then as we continue, we'll talk more about hyperMILL, but we've got a page here that shows their contact information if anybody decides that they want to get a hold of them. So let's get on to the part, the order of operations, and we had some interesting limitations here, Aaron. I'd like you to tell us a little bit about the machine that we were using.
Yeah, so we used a Haas tool room lathe, and kind of, I don't like to say unfortunately, that was the only machine that we had at our disposal at the time. And some of the limitations are, one, in RPM, but two, it's a light machine, and I believe it only weighs about 4,000 pounds versus a turning center of the same size would probably weigh almost double that. And so there are some considerations to be made on feeds and speeds where we might have to kind of compromise a little bit and dial things in a little bit more slowly than we would on like a typical turning center if we were going to do production on something like this. And so there are some limitations.
When you say compromise,
Yeah.
tell me why are you compromising? Why are you being forced to compromise, or is this just because you know the limitations of the machine, but you're trying to find out if this tool is going to do a good job on this machine despite those limitations?
So a little bit of both. And so it's a great machine. It's not a production machine, and so it's when I mean like some of the limitations, I say it's a light machine, and so the heavier a machine is, or the heavier the casting, and the more robust it is, the heavier the cuts are going to be, the better you can hold surface finish, and the better you can hold tolerance. And so when you don't have those, it's kind of like using maybe a light duty manual lathe, except we have the CNC programming capabilities. And again, it's a great machine depending on what you're using it for, but you have to take into consideration those limitations and maybe dial back your feeds and speeds than what either is suggested by the tooling manufacturer, because we'll run into chatter problems, on the surface finish. We might run into taper issues that we might have to program out of it. And so there's issues will arise that maybe we wouldn't have if we were using a more robust machine.
Okay.
And so
what about like a lot of the modern lathes nowadays? They're using collets.
Yep.
And they're using bushings.
Mm-hmm.
This lathe has a 3-jaw chuck.
Correct.
Does that present any unique challenges?
Yes. And so, a 3-jaw chuck, it does, and that also has its limitations in just the clearance, tolerance of, the way the jaws move in and out.
Mm-hmm.
And so it's not going to run as concentric as a collet would. This particular chuck does have a faceplate that can be dialed in and indicated in, and I did indicate it, before we started. I indicated in as close as I could, but the repeatability of taking the part out, putting it back in the jaws are going to have some variability in them. It's not the same as having, like a collet system. So one of our turning centers that just, it was not available for us to use at the time, but has a royal collet chuck in it and collets, and those are repeatable to I believe a couple tenths.
Yeah.
And it would have been nice to use something like that, and so maybe next time.
Yeah, but I mean, this is also nice, right?
Yeah.
Because this is real world, right? So, I mean, we have what we have, and we have to make do,
Yeah.
right? So I wouldn't have a job, right? If everybody had a perfect setup all the time, right? Because that's where I come in. That's where I help people dial their process, choose the right cutting tools, right? And we'll talk about some of that, why we chose some of the grades and some of the geometries that we chose based on this machine, right?
And I actually really enjoy the troubleshooting aspect of that.
Yeah.
You have to make, and a lot of shops are like that today, and I tell my students that it's, you might get a blueprint and envision the perfect program, and then you go out in the shop, and those aren't the tools that you're presented with. It's like, you're limited to, what you have, and you might have to make accommodations for that. And I just want to add, the last thing I want to add about the machine is that I guess the other probably primary limitation is, we don't have the capability to automatically change tools. We don't have a turret that we can load a bunch of tools in, and so we had a quick change tool holder like we would have on a manual lathe, but because of that and that we're changing tools manually, we chose to do each operation as a separate program.
Yeah.
And we would, it seemed to be the most efficient way to do this, where we treated, the turning and then the NPT thread, and each operation along the way as an individual program.
Yeah.
And again, not ideal if we were doing production, but for this, it actually worked out, quite well.
I feel like it worked good too. Yeah, I mean, I guess we could have thrown some program stops in there and some notes to change the tools, but
Yeah.
I think that's probably more risky than it's worth, right? Like it's good
Possibly,
to just have a different program.
I think it offered us a little bit more flexibility.
Yeah,
Yeah.
yeah, absolutely. So for the first, we broke this part basically into 3 setups because of the situation that we were in with the tooling, with the lathe being what it was and the way that we were using the tooling. So we broke it into 3 different setups, and the first setup was an OD turning operation. And I think we've got a picture.
And so it's a pretty
what
aggressive
our,
cut for a groove tool, but you can see that there's
we
no
got,
chatter. The
video
chips
up
are coming
now.
off
I
nice.
think we've
We're
got a
roughing
picture
this
of
in
what
2
that
passes,
operation
and then we're
looks
going to...
like, though. So I don't know if everybody can see the red line there, but the red line is showing our cutting path. Remind me, what bar size did we have here, Aaron?
We started with a 1-inch bar stock.
1-inch bar. Okay, and we're turning this down. We're turning the taper for the MPT thread as well as the OD. And we had not only size to worry about, but we had a surface finish call out on there too. And so we'll look a little bit at some of the inspection data a little bit later, but we had to be mindful of that. So we broke this operation into roughing and finishing,
Correct.
right?
Yep.
And what did I do with the roughing pass the first time around?
So the tool that we were using was a dog bone insert, and I kind of call it turning with a grooving tool. And I have to say, when we hit cycle start, I was a little bit alarmed because when I heard the noise, I was absolutely certain that we had snapped the tool.
Yeah.
And we had accidentally programmed the tool for 30 thousandths per revolution instead of something a bit slower. And much to my surprise and kind of admiration, actually, for the tool was completely intact, and it had turned the diameter. And
Yeah, the noise we heard was the chips hitting the window, not the tool hitting the window.
Yeah.
Yep.
And so I definitely have to give credit to the Vargus tool for the durability, and it certainly gave me a new vision on what that tool can do. So
You didn't plan it that way, Will?
No, it's not usually a great thing to forget zeros, but sometimes it happens, right? And it's nice to know that you've got a tool that can withstand it, because that kind of thing happens more than you would think.
Well, I think I commented at the time that might be the perfect tool for a lot of my students because it would hold up to some of the oddities that we come across with some of their programs.
Yeah.
But we adjusted the feed rate. We ran it again, and again, I don't have a whole lot of experience using an insert like that, but it was for a profile insert of that style. I'd always been taught years ago that those type of inserts, like a grooving style insert, but this had a full radius, couldn't take a lot of the lateral force in turning.
Mm-hmm.
It was all supposed to be radial, as you plunge in with a typical groove tool. And, the depth of cut that we were taking initially before we, were experimenting with a couple things, I believe was 40 thousandths per side, I think, or something close to that. And I think we settled on maybe 12 to 15 thousandths per revolution, maybe, was it, or somewhere around there?
Yeah, when we started, I think actually we were taking almost 60 thousandths per side.
Okay.
And
Yeah, I
we
thought it was
decided to
pretty...
break that up a little bit because there was a little bit of the part left on the holder afterwards.
Yeah.
But I think we've got a picture of this tool up. I think it's the next slide. There we go. So that is the tool that we had, right? It was a full radius. It was a 4mm dog bone, and this tool has a nice chip breaker all the way around it, right? It is designed to groove and turn, right? So you can plunge and then you can move sideways with this tool, or you can open up a big pocket and then clean it out, as long as you can, withstand the radius that's on that tool. Or, you can open up a big pocket with that really fast, because this will take an incredibly aggressive cut, and then you can come back with something with a smaller nose radius and clean up your corners if you need to. But yeah, I mean, this particular tool, I really like working with these a lot. I've got plenty of stories where we started, in the middle of the recommendations for the book, and ended up, 2 and 3 times faster than the high side recommendations. This tool, especially when laterally cutting it really relies on very high tool pressure, because we almost need, the tool's really not going to move, but we need to get the material hot enough so that it flows well when we're cutting, because we're not a super sharp insert. And obviously we've got a big radius on here, so we really need to get a ton of tool pressure, almost to the point where we get deflection with the part and or the tool holder, and then it gets into its zone and it's just chips are flying. You get these really nice heavy number 9 chips off it. It breaks chips real nice because of its geometry, and I think we've got a video of it flying here too.
Well, I was really impressed by the tool.
And so it's a pretty aggressive cut for a groove tool, but you
So,
can
yeah,
see
here it
that
is
there's
in
no
action.
chatter. The chips are coming off nice. We're
And
roughing
you can
this in
see
2
it's doing a great
passes, and then we're
job
going to do one
breaking
finished
the chips,
cut.
right? It's not getting
And so
a
what
big
this
bird's nest
operation
there,
is
and
doing is
even
it's
without cool, I mean, we got a
cutting the
little trickle
taper
there,
for the
but
NPT
there's really
thread,
no coolant to
and then
speak
it's
of on the cutting
also
edge.
cutting the diameter for the first part of the
See
shaft.
Aaron in the reflection there.
Yep.
And so it's a pretty aggressive cut for a groove tool, but you can see that there's
Sound
no
that-
chatter. The chips are
we
coming
can't
off
hear it in
nice.
here because I didn't turn the volume up on that screen. But how did that sound to you guys when it was going on?
Oh, it sounded really good. You could hear the chips breaking up nicely. I mean, the one thing you don't want when you're turning is long, stringy chips. You want them to break up nicely and break off and fall, fall down, and that's what they were doing.
And that's what I was. That's all I want to know about is from the sounds of things.
Yeah.
You can kind of tell something's going wrong, like you
Oh,
said
100%.
earlier. So if there was an issue there, you would have heard something going wrong.
Yeah, 100%. And that's one thing I tell my students a lot, and it's really hard to teach. Unfortunately, it's just something that comes with experience, is that you can really, and that's why I really discourage like the earbuds and the music and when in the shop, because
Right.
I said you can tell so much by how a tool is performing by listening to it.
Yeah.
You know, even sometimes more than seeing what's going on.
Yeah. Well, yeah, I mean, for that, honestly, I know you guys don't think I'm old enough, but I miss machines that were manually controlled, because you could feel what was going on
Yeah.
through the dials.
Yep, 100%.
And now nobody knows what that feels like.
There's an article in the September issue of Cutting Tool Engineering that addresses this very subject in terms of teaching students, teaching newcomers to machining, to ensure that they do have exposure to lessons on manual machines, so they do get some, I mean, you need the experience with it to have that wisdom when you move forward to the CNC world.
Yeah.
And it makes it a lot easier, actually. We had 2 manual machining classes when I first started at Harper, and now we have 3. I added a third one because I do think it's so important to learn the fundamentals there. And like Will said, touching, feeling the vibration, smelling, seeing, hearing, and you get to the CNC, and a lot of it's just the numbers at that point, and hopefully hearing and maybe watching a little bit, but it's funny. I've had some robust discussions with some people who have toured our program and have suggested, why are you wasting your time with manual machining? These machines are old and outdated, and we don't do production anymore. And I said I can't stress enough how important that is. And I really do think it accelerates a student's or anybody's, kind of understanding of the whole machining process.
Yeah. Well, and I mean, realistically, every shop I've ever been in, no matter, what brand of machinery they have and what they make, they all have a bridge port and an engine lathe in the tool room.
Yeah.
So knowing how to walk up to those machines, being comfortable walking up to them and being able to make things square and round, and take that part over to a surface grinder and get it to fit where it needs to fit when you're trying to make, a setup piece, or when you're trying to make a gauge or something that you need for inspection. Being able to do that manually is a huge part of any machinist's job, really.
I had the opportunity last December I took a trip to Germany to learn through the school to learn more about their apprenticeship programs over there, and I know Germany's always been considered to be kind of the best at apprenticeships.
Yeah.
And what was really enlightening and kind of heartening was that we're doing a lot of the same things that they were doing. And again, they start them all out with hand tools and even like filing a part to fit. And it's like, and I said, at first I wasn't thinking in that direction. It's like, well, we want them to know what a fit is and how a precise fit, how 2 parts should fit together.
Yeah.
And this one lead mentor that I was talking to, and he said, nothing provides that than a hand tool.
Yeah.
To because they can take a little bit off and then fit hand fit the part, and then they go right into manual machining in lathes and mills and grinders. And so it was really nice that I'm like, yeah, we're doing a lot of the same things that they are for our students and our apprenticeship, our apprentices too. So
Very cool.
yeah.
Yeah, that is an interesting aspect, and Aaron and I will be doing some other discussions on the side to explore that a little bit more. But that is really interesting about how widespread that mindset is about the need for manual machines. I mean, there is some like group out there that thinks, well, we're past that, we don't need that anymore. But it informs your future and your future use of CNC. So it's kind of hard to teach that without them putting their hands on the wheel and
Yeah.
feeling it.
Well, it's kind of interesting, and I didn't mean to cut you off.
No, you're
I
just
did.
fine.
Okay. And I don't know if it's unique to the Chicagoland area, but there's actually, and I'm not going to say it's like big numbers, but there's actually a fair amount of shops that are still all manual in this area, only because I've talked to them because they visited Harper
Yep.
looking for people. And I had a person last year that was that visited me at the school and was almost in panic mode. And he said he had, I believe it was 12 machinists. They had all manual machines. Can't get anyone young because they come in and they don't want to work on something that looks like it's from World War II. They
Yeah.
want to work, on the fancy machines. And he said, my top guy out there is making $65 an hour
Yep.
on a manual machine. And he said, we found that for the product that we do, we are just as efficient on CNC or
Yeah.
as a CNC machine, because he said all our jobs are 2s and 3s and 4 parts.
Yeah.
And he goes, we are very good at what we do, but and he goes, my youngest guy in the shop is 57.
Yeah.
And so he said, I'm in panic mode that he said half my workforce could retire tomorrow.
Yeah.
And so he,
Could you did say $65 an hour,
Yeah.
right? And is he
That's what he
working
told me, yeah.
full time.
and he said with overtime, I think he told me he had, I think he told me he had 2 or 3 people that were making over $150,000 a year.
Yeah.
Well, that tracks, because just
Yeah.
at that rate, 40 hours, that's 135.
Yeah.
And I think that's an important thing to mention to anyone outside of the industry who might be listening and watching. This isn't just us saying this because we're involved in this industry. This industry pays really well, and it is not, I mean, even if you're on the manual machines, it's still very safe these days. You got to pay attention to what you're doing, and you can't drink bourbon while you're on the shop floor, contrary to what we might be implying here.
Right. Yeah.
But,
I think that maybe used to happen, but
it's definitely safer and cleaner and brighter than what you might be thinking. But it's, the idea that it's a well-paying job, it's not, that this gives you some,
yeah.
some perspective on what does that mean, a well-paying job.
And I think
135,000 to 150,000.
Yeah.
I mean, you're working hard for that, yes, and you might be working 60 hours a week sometimes, but that can be good. And if you really like what you're doing, I mean, anyway, I'm going off topic here.
No, but I mean, this is important to discuss, right? Because this is an issue that I see at every shop that I go to, right? People are having a hard time getting people, and people out there just really don't know, like, hey, look, if I learn how to do this, then I can go into a shop and I can make a livable wage with no student debt.
Well, I get a lot, and I wouldn't say a lot, but I do get calls from some manufacturers, and it's like I can't find anybody.
Yeah.
And my first question is always, well, what's your starting wage? And there's still some people out there that I've talked to recently. It's like, well, we think $15 an hour is fair, and I'm like, they can work at McDonald's for that and know absolutely nothing. And I said, even an entry level person, has some skills to bring to the table. But what I tell my students. And this was just from my experience, you can start as an operator with no experience and make, not a whole lot. Once you learn how to set up a job independently and can run it, that is the first big step, because now me as, like, say, a manager or something, I can give you a print or a program or whatever, and now you can work independently, and now I can go do, my time is probably better spent somewhere else, but now I don't have to worry about you. So, you're worth $5 an hour more to me because you can work independently. And so, trying to get that mindset to my students to work hard while you're here, because that's going to put money in your pocket.
You're just going to start at a higher level when you start.
Yeah.
Exactly.
Well,
and that's key, I think. Yeah.
And that goes back to what we were talking about. I mean, learning the basics with hand tools.
Yeah.
Right? Because if you don't know what flat means, if you haven't learned how to file something flat, you're not going to be able to machine something flat, right? If you don't know what happens to a drill when it goes into a hard spot in soft material or a soft spot in hard material, if you don't know what happens to the hole, right, and how to inspect that and how to adjust for that, right?
Right.
Then, yeah, maybe you can set up a machine and touch off some tools and make some offsets, but then you don't know if your first part is good.
Right, and I do think you need to be well-rounded. And again, I'm sure this is stuff we'll probably talk about in future conversations. But just some of the students I get is they're video game kids,
Yep.
and they're very electronic and they're very adept at learning that stuff, but
Yep.
they don't want to learn the manual stuff. And so when I first started Harper, we had an adjunct instructor, and he was a young guy, an absolute whiz with software. I mean, it was like the stuff he could do in his head. I was thoroughly impressed, but the machining experience was not there, and so you'd hear the machine just screaming. And it was always like, well, that's what the software told me to run. And it's like, you don't want to be a slave to the software. You want to
Right.
control the software.
Yep.
You don't want it to control you.
Yep.
And so that's why we try to, hopefully not just us. I'm talking about the other colleges in the area,
Yeah.
and I know some of the other instructors, and we do try to offer, that balanced approach that hopefully we can cram as much down as we can in the short time that we have them, and then send them out to be. And like I tell some of the manufacturers, I go, you're not going to get a journeyman, but you're going to get someone hopefully that's very trainable.
Yeah.
that they will be willing to learn whatever you want to show them.
Well, don't make them too good, because then I won't have anybody calling going, I got chatter on my threads.
Yeah.
So I think I should mention the $65 an hour isn't something that somebody's going to make right out of school. What would you say would be a typical, and just give me a range, don't give me an exact.
Yeah, so right now I'm seeing a lot of students, and again, even with the 2-year degree, I say they have no experience. I mean, that's just kind of reality.
Mm-hmm.
They're trainable at that point. But I'm seeing anywhere between like $18 and $23 an hour, which is not awful. That's still with benefits and maybe 2 weeks
Livable wage.
vacation.
Benefits. That's the thing. It's benefits. I mean, this is a real world career.
Yeah.
Really,
And-
it's the start of one.
And the one that like comes to mind recently is I had a young lady, and again, this is not. It is still a male-dominated industry, but it's opening up.
Yep.
And I had a young lady that came in, completed the program, and I kind of gave her 3 places to interview that I knew were looking, and the one she selected, I believe they started her at $22 an hour, and then I heard from her maybe 9 or 10 months after that, and this would have been like last spring, and in that short time, she had moved from basically an operator to a night setup person, and then they had moved her to days to basically run a horizontal machining center cell. I think it was 3 cells.
Wow.
And she had gone from like the $22 to like $27 an hour in less than a year. And I recently heard from her a couple weeks ago, and now they're training her to be one of their programmers.
Yeah.
And so I'm guessing once she completes that training, she'll be, in the 30s, and that's all within the, time span of a couple of years, which is, pretty incredible.
Absolutely.
And that's all without any significant educational debt to pay off the
None.
education
Well, I
she
mean,
got.
And, and to that, we actually have quite a bit of scholarship money, and unfortunately, there's money left on the table every year that students don't use, and I don't know what it is, but it's like pulling teeth to get them to fill out a piece of paper, and I'm
Yeah.
like, you don't have to pay this back, and
Yeah.
they're like,
And we'll cover this
Yeah.
in another different side episode kind of a thing, because that is an important part for the mainstream audience out there, because it is incredible how under the radar this careers in machining.
yeah, like
have
Haas.
become.
And again, we have all Haas machines, so I will plug them a little bit.
Yeah.
I think they do an amazing job. There's there's that subset of people that, you know, kind of knock them. It's like, oh, well, you know, they're not, you know, some of these other high tech machines. I think they're put together well.
Yeah.
We've had very few problems, and I mean, our students, you know, do some things that
Yeah.
it would probably get you fired if you were in, you know, in a job setting.
Yeah.
And they're hard on the machines, and I really don't have anything bad to say about these Haas machines. And Haas does a great. They are so supportive of manufacturing education that we qualify every year for Haas scholarships, and a student
Excellent.
can get up to $2,500 a year
Wow.
that they can use for tuition and books. And I mean, that's like, if you take classes full time at Harper, that's like a third of what you'd have to pay for a full year of classes.
Yeah.
Cheers
that's-
to them.
Yeah,
man.
that's
really.
they really do a good job with that.
That's a cool program.
We probably should get back to our
To parts,
subject.
yeah.
I'm sorry.
Yeah, no, it's all good. I mean,
I
we're
can
just
hear Josh in my ear. Like, get
we're
on
just
track.
having a good conversation here, and you know, where it goes, right? So, where did we leave off? We were turning the OD.
Yep.
So I think we've got a picture shows our tool path, and then we've got a little snip of the code that was posted from hyperMILL. So I think it's the next slide. There we go. So that was our tool path. So we had 2 roughing passes and a finish pass, and then the next slide shows the code as it was posted. And this wasn't our this was our finished code. Yeah. So we had 1,800 RPM and 12 thou feet per rev. And then if we go on from
And again,
there,
we were limited by the RPM with just the machine. That
that's-
machine was limited to 1,800 RPM. So
But that's
I mean,
okay. I mean,
yeah.
we would have liked to run it faster, but you know, realistically, again, this is why Vargus has me, right? So when we can't run book parameters or whatever, right? That's people call me and say, "Hey, I need some help," and I go out there and, you know, we do programming for people. You know, open up my laptop, open up hyperMILL, do programming for people, things like that.
You are going out there to help the shop get the most out of that tool with the machine tools they have.
Yeah, I mean, we
Basically.
more or less act as manufacturing consultants, right? We help people choose process.
Yeah.
We help them refine those process, right? I mean, we are application engineers. We are loyal to Vargus, right? So, I mean, at the end of the day, we're going to say, here's a process for you to use with a Vargus tool, but we don't ask anything of anybody other than to just buy the tools that we recommend, and all of that service comes in the package, right?
Right. And
Well,
that's maybe a hidden part to some. Maybe those who are more experienced in this industry understand all that already, but maybe not.
But even when they
so
do,
that's
I
what we
mean-
want to show here. This whole kind of approach is going to kind of reveal some of this, what's going on beyond the sale.
Absolutely, right? And, you know, as far as people understanding it, I run into a lot of people who say that they've been a machinist for 30 years and they know what they're doing. And for a large part, they do, right? But we work primarily in threading. That's been our reputation for the last 60 years. We obviously have more, you know, we just talked about one of our turning tools. But I run into a lot of people who, you know, after 30 years of machining experience, still don't know much about threading, right? And so I think the next slide that we have, we start to talk about threading, actually. So we have here we did we actually did a 14 pitch MPT, but this was kind of interesting. We used an 11.5 pitch NPT insert, and we could have used a 14 pitch MPT as a full profile, but we decided for this to use it basically as a partial profile insert, right? And then we had our holder, which was a 3/4 inch holder for some of our standard product. And then we had an anvil, was a YE3. And I think our next slide shows our holder and our insert. So here we chose VT10. We chose the VT10 grade specifically because of some of the limitations that we knew the machine had, knew that we wouldn't be able to go extremely fast, right? So we wanted to have a fairly sharp insert that was free cutting, but also that was very tough and could stand up to heavy cuts and maybe a little bit less than ideal situation, right? So when we when we started this process, and actually I'll say, let's go to the next slide and look at the video. So the video that we have, this was, I think, maybe the first thread that we cut. And you'll count, there's way too many passes here, but we just decided we're gonna start on the safe side, and we'll get something going. So we got going here at 1800 RPM, and I think there was 18 passes. It might have been 17 plus 1, but I'd count 18 watching the video.
Well, that's 17 plus 1 is 18.
17 plus 1 is 18.
I
but
was 17 cuts in the spring pass, I
yeah,
believe.
yeah, okay. So, yeah, the plus 1, for people who might not understand the lingo, is basically a spring pass or a free pass that would, in theory, have no cutting pressure, but what it does is it would clean up any small burrs, boogers, or surface finish imperfections on the thread, right? And then if we go forward to the next slide, we've got the code that we posted there. And here you can see the D 0.005 in parentheses. In this case, that's the depth of our first cut, and that calculates them, because we're using a modified volume cut, that calculates the rest of the cuts, maintaining constant volume during the cutting process. And we increased that 3 times, a factor of 3, to 15 thou, to get correct cutting parameters. We ended with, I think that's 12 plus 1 on this machine,
Correct.
right?
Yep.
We made some other changes, right? We started with a flank in feed, so the A60 there, and we changed that to a 58, and basically what that does, that makes sure that the insert only cuts on one side, and it really limits cutting pressure, prevents the insert from bouncing back and forth during the cutting operation.
Correct.
And gives really nice, smooth, clean threads. And I don't know if, probably can't see here, but we can see when we talk about the metrology on this, the surface finish.
Well,
on
again,
those threads was excellent.
before you had come in the spring, and then again with this situation, I had not had any experience with Vargus tools. I've done a fair amount of threading, manually and CNC, and I pretty much always use like a top-notch insert.
Mm-hmm.
And Will and I had talked about this before, that when he had come into my class, it startled me so much. We'd done a half 13 thread,
Mm-hmm.
and I think it was 4 passes,
Yep.
and it was as fast as the machine would go. I mean, I thought the threads were going to be torn out, and we opened the door, and not only were the threads perfect, but I mean, the surface finish on it was. I was blown away by how well it worked, and
Yeah.
kind of the same with this too. It was definitely a testament to the cutting insert.
Yeah.
Absolutely.
Yeah, and I mean, having the the backing of a company like Vargus, right? I mean, they have great product, right? And then hopefully, they do a good job, and they hire guys who are able to run the product well, right? So, and make recommendations, because we see that all the time. We go into places and they're like, well, our other insert, we use 35 passes, so we're going to use 35 passes with yours. And you can, if you like long machining times, if you like, tools that wear out fast, you can. But, these are new grades, and they're designed to run with new parameters, right? We're not running high-speed steel anymore. We're running carbide, and there's a lot of engineering that goes into the grades of carbide, and there's a lot of engineering that goes into the surface treatment and the coatings that go on the tools that allow them to perform well at, high RPMs, at heavy chip load, and, give excellent tool life, excellent cycle time, you know, and realistically excellent surface finishes too.
And I've, and after, after I kind of got out of the industry, after, my company sold, I'd done a little bit of consulting here and there, and it's actually kind of shocking to me, especially with, the whole continuous improvement movement, how many companies are out there that you run into people, it's like, well, we've always done it this way. And it's like, when you challenge them to a way that they're doing it, and that's one of the big things that I try to tell my students is that when I went to school and learned, we were trained to be self-sufficient. And it's like, you learned all the, the feed and speed info, and you learned how to select the grade of carbide and, and all that. And, when I was a young machinist and, you're kind of arrogant because you have that training, it's like, well, I know all this stuff. I was really humbled by, my tooling guy, and this was, 30 some years ago. We were having problems with a certain job, and he came in and wanted to offer a tool that was 3 times as much as the one I was using. And at first you're like, this guy just wants to, make his car payment on selling me tools.
Yeah.
And without going into detail, not only using his tool, not only did we used to only get 1 part out of an end mill, now we got 7 slotting this part, but we had reduced the cycle time on this particular job that I had been doing from, I believe it was like 70 some minutes down to 17 minutes.
Oh
Yeah.
my God.
And it was such a light bulb moment, and now it's one of the things that I preach it in almost every single class that I teach. It's like, we're going to go through this basic stuff so you know where the information comes from. But, whether it's Vargus or any of these other tooling companies, they spend millions of dollars every year in R&D learning how to make these tools cut as best as they can in all kinds of situations. And yeah, they want to make a buck selling tools, but they also want to help you as their customer.
Yeah.
And I said, whether you're setting up a job for the first time on production, whether you're having a problem with a certain job, whether you have a special, call your tooling guy, because I said he or she will be able to help you solve this problem. I go, that's what they're there for.
And they have a vested interest in making sure they help you in the right way. Because
Yeah.
the longer you're around, the more they can help you out.
Absolutely. And I mean,
Absolutely.
it is
that's-
such a word of mouth industry as well. I mean, it's, if you do a good job here and, you talk to your friend who's also in the industry, I mean, it really does go a long way.
Yeah.
You know, we're going to go over our time. I just want to let everyone know that because we still have a ways to go to finish
Yeah,
for
and-
today.
and
I just
we're
want
just
everyone
fine.
to
I
know
think
watching.
Tim-
I hope you don't mind. We're going to keep going.
I think Tim gave us a little extra
Yeah,
time on
he
the back
did.
end, right?
He did. Yeah,
Okay.
yeah.
So we got, well, just because I was thinking about it,
Go ahead.
that TMDR, I know it's off topic, the thread mill that was able to make its own hole.
Yes.
I'd like you to just talk
Sure.
about that, because you were telling Joe in the back, and I just thought it was a good story.
So again, I had mentioned earlier that Will came into my class and we had set up some demos, and he said, this is what I want to do. I want to do some OD thread turning. I want to do some thread milling. And it was a great opportunity to show my class, these live demos.
Mm-hmm.
And I thought, I'm going to be proactive. I'm going to have this plate already prepared. So when Will comes in with the thread mills, and he had dropped the tools off. And so I had taken this plate and I had pre-drilled these holes. And so we had, I think, used the first 2 thread mills. And then he said, and Will kind of laughed, and he said, you actually drilled too many holes. And I'm like, well, for what? And he said, well, this thread mill doesn't need a hole, a pre-drilled hole.
Yeah.
And I was not familiar with that.
Yeah.
And I'm like, what? And so, I made a quick adjustment to the program, threw another plate in there, and away we went. And I'm blown away. And again, I've been doing this a long time, and and you kind of alluded to it before. You run into machinists all the time who have 20, 30 years experience, but unless you're keeping up on all the technology all the time, and I mean I've thread milled a fair amount, but I'd never seen this thread mill, and to see it make its own hole and then make the threads at the same time, I mean, again, I was blown away. It was the coolest thing.
The reaction of some of your students was pretty priceless, because you could see a couple guys, because we didn't really announce what we were doing, and there was a couple guys who were like, "Oh, it's gonna crash!"
Yeah.
As the tool's just rapiding towards the part with no hole in it, and then all of a sudden you just hear a nice little cut sound, and then comes back, chamfers the top of the hole, and it's done, and everybody's like,
That is very cool. I mean, and it goes back to having a good relationship with the companies you're getting your tools from.
Yeah,
I mean, because they're going to help you keep on top of the
and
technology.
I love it. I mean, I have, even after this long of being, not only in industry and now in education, I have such a love for the curiosity of new stuff and pushing stuff, and it's just like, I was like a kid in a candy store that day. It was just like seeing this stuff, happen and operate. I loved it.
Yeah.
It was really cool.
Yeah.
And I love that perspective too, because you know what it used to take, and now you're like, wait, you're skipping all that.
Well, and again, I realize we're off topic, but it always used to be, and again, this is 30 years ago, that if you needed to get a high volume of parts out, you're not going to thread mill, you're going to tap it, because you can do it way faster. And I apologize, I don't remember what the model number was, but I mean, this thread mill dropped down in the hole, and it was like zip, and it was out.
Yeah,
and
that was our mock.
Yeah, and it was as fast as tapping a hole. And not only now do you get the precision and the adjustability of being able to adjust your tolerance on the fly with a thread mill, but it was just as fast as tapping a hole.
Well, and realistically, probably the biggest benefit of thread milling, whether it's one part and it's a $75,000 part, or it's a high volume shop, is that if you break that thread mill, you get your forceps, you pick up your broken thread mill, you put it over there, you put in a new thread mill, you touch off your Z, and you go back and you do the same hole again. As long as your Z is set the same, that thread mill can go again. If you're in, if you're tapping, then you're going over to a tapping stand and you're trying to manually tap that, because now you can't line up that first thread with a tap. You'll never have it lined up.
And if you break the tap, I hope you have a tap burner.
Yeah, yeah, exactly. You're gonna need a discharge machine to get that tap out, or exactly. But I mean the mock, in a lot of places is getting that reaction, right? It's, we've done tests for, plenty of customers, plenty of them who have, either maybe never thread milled something, or, just loyal to tapping, and, we go and we get, better cycle times, and better tool life, in almost every case, and better quality threads, right? Because the tap at some point has to stop and then retract, and so you always see those marks in the thread, and that thread mill cuts all the way in and all the way out, and you don't see that. I mean, there's different things that you see with thread milling, but it's not those lines that tear up bolts as you thread them into nuts.
I think the whole reason for this podcast series that Vargus is sponsoring, it's because there were so many case studies or case histories or testimonials about the mock products that the customers were really happy with the results, and there were some major changes in the results that for the better.
Yeah.
That led to their wanting to come up with a different way of getting the word out, and so that is why we're doing a podcast.
Yep.
But it is part of staying on top of the technology in this industry, and it would be easy to just do it the way it's always been done. Right. It would be easy to do that, and because if it was successful at first, why isn't it successful? Why isn't it successful now? I need another drink.
And it's one of the phrases, and I tell my students this, and I've told employees that, previously, that is the phrase that, basically I will fire you for if it's the way we've done it. It's the way we've done it, and I'm like, I don't want to hear that. I want it the best way, not the way that we've done it.
Yeah.
You always have to be curious at your process and always looking at it and like, is this the best way that we can do it? And I do. It's very easy to get complacent. It's like, oh, it kind of runs okay, and we're not really having a lot of problems, but maybe we have a 7-minute cycle time, which is
Got
okay. But
plenty
maybe
of
we can
time
get
to
it.
play Minecraft while this cycle runs.
Exactly.
I used to think,
Yeah.
why do we cover the same topics in the Cutting Tool Engineering magazine from one year to the next, or every 2 years? You see a lot of the same like general topic areas, but there's a reason that I learned eventually. It took me a few years, but it's because the technology is advancing so quickly.
Yeah.
You need to tell people about the best way to use the new tools to
Yeah.
get the best use out of them, and sometimes the speeds and feeds and all that stuff, you have to relearn what the best approach is. So all this evolution, it continually pushes us to be more productive, more efficient. So anyway, let's continue before I get the hook from the back room.
Absolutely. So after we cut the thread, we had to pull the part out and flip it over, and I think we've got another slide. I think it's 17. Shows the second side of that part. Obviously, it's not a in-process print, right? It shows the finished part, but that red line there shows the tool path that we took. So what did we have here? About 7.25, 7.5 inches to turn, something like that.
Yeah, it was about that.
So we had we actually had more than that sticking out because we wanted to get past that groove for the second operation. So we had 8.5 inches out of the chuck, something like that.
Yep. And then we turned the OD, and then we did another operation where we put the grooves in.
Yeah.
The OD grooves.
So we did I think 8.5 inches, maybe 9 inches out of the chuck, and we had it supported by a tailstock. And we turned that with the same VG cut insert that we had shown previously. And I think a couple slides forward, we got a video of that turning. And I think it's, here it comes.
And you tried to run this without coolant. I mean,
Yeah.
and I think it starts off with it, but then you shut it off.
Yeah, coolant goes away.
And that was only for video purposes.
Well, yes and no. I mean, this kind of steel can run without coolant.
Okay.
That some people, especially for milling and steel, prefer air blow over liquid coolant. And if you have to do 2 parts like we were doing, you're not going to cook your tools using no coolant. And sometimes it's nicer to see what you got going on. If you're doing production, obviously tool changes cost money and take time, so you want to manage your heat best you can. But, in this case, we were just fine to be able to run, with no or limited coolant for these operations. I think a couple slides forward, we have our code, and it shows our cutting parameters, and we ended around same as we did on the front side, right? So we had 1,800 RPM and feet of 12 thousandths. Yep, for roughing anyway. I think we kept the same for finishing. I don't remember, but just a little bit different depth of cut. And then,
just so I know that, and I clarify for anyone watching, the code that we're looking at here is from the hyperMILL code?
yeah,
that you-
exactly. So
that you put together?
hyperMILL posted this code for us to run on this machine for this application. Yep.
Okay.
So basically, I mean, they've got a CAM software, right, that they
Yeah.
build, and in that software, they're able to take a 3D model of the part and then extract lines from it and bring the cutting tools up to those lines, right? And basically, by mapping a path of the cutting tool on that line, they're able to make a machine movement or a machine path, right? And then they post that out, and it comes out in this what we call G&M code. And they have a very good library of posts. They're able to post for just about every machine that I've ever had to do a project on. So
And if somebody's looking at this right now, can they adopt, like, take a freeze frame of this or a screenshot of this and be able to use it if they know enough about how it would fit into
if they've got a
something they're doing?
similar part and a similar insert, maybe, but all the code is specific to the application that you're using, right? So, we might tune it differently. If there's less parts sticking out of the spindle, we might be able to go faster. If there's a machine that's got higher RPM, we surely would go faster, right?
Yeah.
But we had those limitations, so we had to find a good recipe for what we were doing here.
Right.
Yep. So the next tool that we used, we kept the same setup, and we switched over to our ST cut. And ST cut, actually, ST stands for Swiss turn, right? So this is actually made for fairly small features, but it's an incredibly robust tool. And one of my absolute favorite features about this tool is the way that the tool comes in and out of the pocket. So setup times are huge. Nobody wants to touch off tools. In a production environment, you can see that screw on the side. You loosen that screw 2.5 turns, the insert pops out of the pocket, you put a new insert in, 2.5 turns back. And the big thing is that you can reach that screw from both sides, right? So no matter how you have that tool set up, you can reach that screw. It's right-hand threads on one side, left-hand threads on the other. And that tool repeats exactly the same. No need to touch it off in between tool changes.
And I have a fair amount of experience with grooving, and especially using small with grooving tools like this. I used to we used to do a lot of jobs of hydraulic spools.
Okay.
That had a lot of small grooves like that, and again, one of the things that we did with this tool is we kind of plunged in, and we made a series of plunges, and then we took that tool and we turned along that the width of that groove.
Mm-hmm.
And the tools that I was used to using, and this was even from I won't go into the manufacturer, but this was from like a manufacturer's rep. It's like you don't want to use, for your finish cut when you're doing the lateral turn with that groove insert, you don't want to do more than 3 to 5 thousandths in diameter.
Mm-hmm.
And I think we were taking 10 to 20 for for a cut after
Yep.
we had kind of done the initial plunges. And
Yep.
so again, it was just kind of a testament to the technology of the insert, that it's definitely a robust insert. And I don't remember the width of it. Was it
So
2
here,
millimeters?
No, here we used a real narrow one. It was just over 1 millimeter
Okay,
wide.
yeah.
But yeah, I mean, we had one groove on here. I can't quite make it out on the one we have printed, but one groove we had was just over 1 millimeter
Okay.
wide. So we decided to use our narrower one. I've had very good luck with these tools. So I mean, obviously Swiss turn, right? Like we run them all over the place, Swiss shops, in hydraulics and medical parts,
Mm-hmm.
right? But we also run these quite often in larger machines. We used a 3/4 inch holder here. I think we have holders up to like 875. Because of that dovetail, it's an extremely rigid work holding. The insert cuts very well. They've done a great job with tool geometry. It cuts really freely. Great job with coatings. We get excellent tool life, and our speeds and feeds are industry competitive. So I absolutely love using this ST cut tool everywhere I can.
I don't think we had any chatter with that groove tool.
No,
At all.
and we got I think, I don't know if I put it in here, but I think we have a surface finish measurement from Alicona later. I think I put the threading information in here, but it was phenomenal.
Yeah.
Yeah, it was phenomenal. And I think we have actually, so I want to show, I don't know if if people will be able to see, but on slide 25, we have a picture of the tool path. And like Aaron talked about, we came in, we pecked all that material out, leaving, I think you're right, I think we had, 10 or 12 thousandths of stock removal for our finish pass.
Per side.
Yeah.
Yeah.
And then after that, we came back and turned. So if you can't see it here, you'll definitely see it when we get to the video. I think we got a video of this one.
Yeah.
Or maybe not.
Tim, do we have a video of this?
If we don't, that's all right. What we'll do is
Yep.
Okay.
So
Yeah,
what are
and
we
there's-
looking at?
There's a couple operations here, but this operation, we're basically just plunging into the material to get most of the material out of the way, right? This tool is very rigid in this direction, so you can plunge in, take fairly heavy cuts.
And this was shot by my son, Tim Spaeth,
Mhm.
who was out there with us at your shop, Aaron.
Yep.
And he was the one who was putting himself in danger standing behind. No, he wasn't. No, he wasn't.
No, we're very safe at Harper.
No, you're very, very, very safe because you pulled me out of there. 'Cause I
Send your kids to Harper. They'll be very safe.
no, seriously, you really will be. Don't worry.
How many years of manufacturing experience do you have?
Oh gosh. Probably almost 40 now.
Okay.
Yeah.
Yep. And you still have 10 fingers.
I still have all my fingers.
Yep.
A couple stitches here and there, but that had nothing to do with machining.
Yeah.
So that's good. Seen
I mean,
a fair amount of stuff that are people that did not fare as well, but
For another episode.
yeah,
Seriously.
another episode. Yeah.
When we were there, we heard about
Yeah.
it, and for another episode, and for mainstream audience especially, because they needed to understand how much safer things are now.
Oh, it's night and day.
Yeah.
But that's really what I'm looking at there. I don't see a lot of like anything happening, but right now that's doing the finish of this thing.
Yeah, I believe we're doing a traverse there. It's kind of hard for me to tell from this angle, but so yeah, I mean, it's like we said, the tool will, you'll have a groove and you'll plunge, 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 and then after that groove is 90% roughed out, we'll come with the tool along the corner. We had radiuses on everything, so we came along the corner. We took that radius off as well as that 12 thousandths of material, came down to the bottom a little past the middle, exited, and then came to the other side, touched the OD, touched that radius, down
Okay.
to the bottom, and a little past
And it
the
just
middle.
keeps repeating. I'm pretty sure that.
Yeah, it'll just repeat. And, we have a couple snips of the code. There's, I think,
next slide?
slide 26 and 27 show the roughing and finish passes. And so we were able to maintain, actually, what do we have here? We had 1500 RPM and 15 thou feet per rev for the finish pass.
Let's
And then
skip ahead
we
to
had,
the code slide.
yeah,
Yeah, I
slide-
was actually a little bit
slide
surprised at how
26.
fast that we ran the feed rate on this, and it sounded great.
Yeah.
We got a
Tim,
great
can you-
surface finish.
Skip ahead to the code slide.
I think it's back actually. I don't remember, but 26 is what I got for a number.
Slide 26. There you go.
There we go. So that was our roughing, and then the next slide was our finish pass.
Skip to the next one. There you go. That's the finish pass.
That looks like it. Yep. So, I mean, again, all this code is much longer than what you see here. I just basically took the startup block so that people could kind of see what the parameters were that we were running. And if anybody wants to discuss it, more in depth, they're welcome to reach out and talk about programming strategy or cutting tool choice, anything like that. Our next operation, we did reposition the part in the machine. We needed to get the tailstock out of the way so we could drill the part. We ended up drilling this part manually, again, because it being a tool room lathe. So we didn't take a video of that. But we drilled a little bit undersize for the thread, and we do have something to talk about there. So our next slide, I think 29. Yeah, there we go. So this was the feature that we were making, and we did pre-drill, and then we used one of our microscope tools in the dog leg holder. There's a couple different names for these, but a lot of people commonly refer to them as dog leg. And we had to open up the counter bore to 0.41, and we had to open up the thread diameter to 0.275. So we used our microscope line for that, as well as threading. And I think we got a picture of those tools on the next slide. So these microscope tools, we have quite a good variety of these. We have with a chip breaker, we have with chip sweep, we have without a chip breaker, we have with coolant through. We have quite a few different options for these. And again, this holder we chose specifically because of having one tool post, right? If we had a turret, we probably would have had round tool holders, and we would have been able to put basically like a bushing or a round tool holder. But this particular system, I really like it because once we got this holder dialed in, we can put any microscope tool in here that we want. It's going to be on center. And this is actually what we did for this, right?
Yeah, and it worked really well.
Yeah.
Like better than expected.
Yeah, the way that these tools are positioned, I know you probably can't see it in this picture, but there's
actually on that left side where it was just that, I believe it was like a cam lock.
Yeah.
And we just exchanged that turning insert or that boring insert for the threading insert.
Yeah.
And everything was identical. Everything lined up perfectly. Was on center, and we just used a different offset for it, and it was good to go.
Yeah, we've got on the back of the tool, we've got basically a chamfer cut at a specific angle. We've got a dowel pin in the holder that locates that chamfer, and like you said, we've got a screw on the side that locks that insert in place. And it's a really great system. We've been having very good success with these, and I think our next slide is a video. You guys can see the microscope boring bar in action. So I don't know what our audio is here. I can't hear it, but maybe Aaron, you want to tell us a little bit about?
So I think I think we were at the top of the RPM. I think we were at 1800 RPM, and using the boring bar, we're using kind of an interesting tooling path. Where it actually started inside the bore, and it would kind of plunge into the bore and then go to the end of the counter bore, and I'm guessing the way that the tool path was set was it probably was more efficient than starting on the outside of the tool and boring how I would typically envision the tool path to be, but it worked great. Again, no chatter. The surface finish was great. And then at the end, it kind of ducked in to that small diameter for the thread, the minimum thread diameter, and finished that to the minimum size, and then it was done. And again, another quick operation.
Yeah. No, these tools are doing a great job. And just so everybody knows here, we were working pretty close. We had a 3/4 inch of thread. And I think we were turning, what were we turning, like within probably like 40 thousandths of that holder to
Yeah.
to get to our full thread depth.
Yes.
Yeah.
Yeah, it was right at the. It was almost at the max length of it.
Yeah.
'Cause I have to say, I was a little bit nervous when it was getting to the end. I was looking at the distance to go a couple times, but no, it was right at the end. And and the one thing I have to say about that dog leg holder was the way that it was situated, not only in the tool post, but the way that it lined up to the part. It ended up being very rigid for such a small tool.
Yeah. Yeah. And the thing when I talk about machining in close quarters, the thing for me that always comes to mind is chip control, because you can't shove your holder all the way up to the front of the part that you're making if you're having chip control
Right.
issues, right? And so the geometry that we used for this operation did a great job of breaking the chip and controlling the direction of flow of the chip, so that we didn't have issues breaking cutting tools because we had a big bird's nest in there.
Yeah, there was no packing,
Yeah.
no chip packing at all.
Yeah. And I think our next slide probably actually shows that kind of interesting tool path. I think that's 32. So that was the tool path that hyperMILL came up with, and that was both unique to both me and Aaron. I hadn't seen that before, and I asked Josh about it, the guy who was doing the program.
Proctor?
Yeah, yeah. And he told me, basically that it's designed primarily to give you a short cutting path, but also one of the things that was really nice about it, the way that it worked, is it didn't push up a big burr anywhere on the part, right? Like a lot of times you're coming back with, in this type of machine, a lot of people will come back with, a file or a piece of emery cloth or something, or maybe, in a little bit more automated machine, you'd be putting chamfers on everything to clean up burrs. But here we didn't really have to deal with any of that stuff, which was really nice.
Yeah.
And there's a little snip of the code for
Next.
both the roughing operations. Yeah, slides 33 and 34. There's a little snip of the code for the roughing operation and also the finishing operation for the bore.
Okay.
And then we get into threading. So again, this was a microscope tool, right? We were able to just on slide 35, we've got the call out for the thread. We were able to just basically loosen that set screw, pull the microscope tool out, drop the new microscope tool in. You did have to touch off for the diameter because the diameter changed on the tool, but after that, we basically just loaded the new code and pressed start.
And we ran a couple parts, and I didn't realize how well it located. Because like with a typical boring holder, I would have expected to have to touch off again between parts, and this located so well that it was, and only because I didn't trust it, I touched off again just to make sure, and the number was right on.
Yeah.
So it was, the way it located was totally key.
Yeah. I mean, we try very hard to make, precision cutting tools, right? Everybody has crazy tolerances now. When you want to talk about tolerance stack, it starts all the way with your cutting tool choice, right? So here we're gonna cut, what is this, 5/16 24 UN 2B. We did have a thread gauge for this. I should have mentioned it for the MPT thread, but I forgot. But yeah, we had a thread gauge for this, and we were able to inspect that thread. We've got a video for you next. I think that's video 6, ID threading. So again, similar setup. 1500 RPM here. I don't remember our pass count.
I believe it was 9.
9? Okay.
Yeah, I think it was 9.
And, for this material, I think that's fair. We might have been able to cut a couple passes out if we really needed cycle time, but, if we're making 1 or 2 parts, we don't have a long time to optimize it, right?
Right.
And
Again, you can see how fast this threading
I think
tool
I'm gonna
threads.
just throw something out here for anyone who might be watching or later watching this. Anyone who wants to kind of come to one of these Bourbon with the Editors to sit with Will here and in Aaron's seat and go over an actual part that they were doing in a similar manner,
Again, you can see
please
how
reach
fast
out.
this threading
Yeah.
tool
That'd
be great.
Will would be glad to
Absolutely.
talk to
Yeah.
you.
Reach out to Vargus, reach out to CTE. We'd be absolutely happy to, host an episode with your part and your process.
I mean, I think it's a good learning experience for everyone just to see what's going on with the technology and what's possible. I mean, Aaron, you're
Again, you can
Yeah.
see how
you-
fast this threading tool
you're
threads.
hitting all the right notes when it comes to just expressing how surprised you are with the advancement and the
Well,
capability of the
Well,
the
and
new
what's
tools.
interesting is, being in education, I'm not, under the gun anymore of, you're under that pressure of getting the part out the door by the end of the week or whatever.
Okay.
And so I do have the luxury of, kind of that, exploring some of the new technologies. And I like to think that I'm up more than I used to be when I was, in industry. And so when I see something new that I didn't know about, like I think I used the phrase before, like a kid in the candy store. I get excited about this stuff.
Yeah.
And I do think, like the manufacturing industry does, we're a special breed of people, and those that have been in it a long time are still excited. I love going into the shop. I love making parts. I love learning about new stuff. It's it's exciting to me, and
Yeah.
to be able to make something. It's I think for people outside the industry, I just don't think it's something that can be expressed enough, because I don't think there's enough appreciation. And we do a lot of tours at Harper for a lot of middle school students, a lot of high school students, kind of exploring career paths.
You do the zone. What was it called?
In zone.
In zone.
You know,
yeah.
for middle school students. But some of the tours that we do, I do this little spiel about, manufacturing, no matter what it is, affects everybody from the time we wake up to the time we go to bed. It could be the vehicles you drive to the clothes you wear. Everything has to be manufactured on something,
Yep.
and somehow, in some way. And you can see the light bulb go off, and it's like it's not just going to the store and it's just it magically appears on the shelf.
Yeah.
It's like someone had to put some thought into how that piece was made, or that whatever that was.
Yep.
Yeah.
And I mean, again, I feel like I've done this a long time, and every time I go to the school, every time I'm making something for myself or students, or I'm thinking about another homework assignment or whatever it might be, like I'm excited about it. Like it's like I think it's really in your blood.
Yeah.
You know what? There's a lot of people out there who like working with their hands and making things.
Yeah.
And building things. And maybe that's gotten lost a little bit because of push to higher education. Nothing wrong with higher education. It's great. Go for higher education.
Yeah.
I'm not saying don't. I'm just saying, you know what? If you're not sure what you're doing and you like working with your hands, try this career in machining, in manufacturing, because it might lead to something even more for you down the
Yeah.
road.
And I mean, throughout my career, I've met some of the smartest people, and you talk to them, and they're passionate about what they're doing for their company, and just like their in-depth knowledge of what they're doing and the process and everything. It's just like I'm always really taken back by how passionate people are in this industry, no matter what it is, whether they're selling tools or whether they're making product. It really is a passionate industry overall. And hopefully I'm able to project some of that on these next group of people coming up. But
Yeah. Well, I'm just keep going. That's all I got to say.
Yeah. Yeah, no, absolutely. I mean, the thing that's really cool for me about the way that we get to work is that I get to see new stuff all the time,
yeah,
right? Every day I go into a new shop. They have new parts maybe I haven't seen before, or maybe they're even similar to, some parts that some other customer makes, but they're being made in a new way, right? So I'm constantly exposed to new philosophy, machining philosophy, constantly exposed to, different people using different cutting tools, right? And trying to figure out, okay, how are we gonna do this? So like being kind of a curious sort, right? Like I love, I feel strange saying it, but I love pushing myself to learn something new every day. And with this, we have the opportunity, right? I mean, even if I say I go into a new shop all the time, and that's true, but even if I worked in the same shop on the same machine every day, I still get the opportunity to push myself, push my machine, push my cutting tools, learn what their limits are, and then say, hey, I'm at the physical limit of what my machine can do or my material can do. Let's find something that can do something more.
Yeah.
And having that ability, that autonomy in your job is really awesome.
Yeah.
I mean, that's really a cool thing that not many people get. A lot of people, you got to sit down and enter data. Okay, that's cool. And there's a lot of different ways to enter data, but not everybody can sit at a desk and do that all day long.
Right.
And if you're at all like, antsy or whatever, and you want to stand up and you want to do something tactile, that's, I don't know, manufacturing is a great career.
It really is.
Yeah.
And you just said it very eloquently. No, you really did. It is amazing. I want to make sure that we're going to be wrapping up here. So I don't know how much.
We're doing
more.
all right. I got. I don't know if you guys want to bring up slide 37. We can show the thread turning code for the internal thread, and you can see it looks very similar to the thread turning code that we used for the external thread, right? The start and stop positions are different, right? Because it's a different diameter thread. And, same P1, constant volume machining, same, 1 degree modified flank angle. Feed rate's obviously changed, because it's a different pitch thread. And then, for those of you who couldn't see it when I was, holding the part up here, there's a picture on the next slide that shows the thread, the part.
Oh, yeah.
So that's the part that we machined in completion. And then we go on to talk a little bit about some of the inspection data.
Oh, this is from Alicona?
So this is from Alicona. Bruker Alicona came out, brought a machine. They were very gracious to give us the time of one of their people for a little bit more than half a day, and did some inspection for us so that we could make the part, inspect it, go back, make process improvements. And it's not that, Harper doesn't have their own inspection equipment, but we really wanted to showcase some of the cutting edge technology in the industry. And so we asked them to come to partner with us for this and to come out and do this. And they were, again, very gracious to do that. So this first slide that you see here, this is actually a surface roughness measurement inside the thread on the flank of the thread. And that measurement, I don't know if you can see it on the bottom, is 0.152 millimeter RA, or basically 6 thou inch RA.
Wow.
Right? Very smooth, and that's in the direction that the thread would turn when it's being locked into the nut, right? So very smooth, nothing there gonna gall or burr or whatever, right? And then they were able to get us another measurement. I don't know if it's on the screen or not, but they were able to measure basically in a 90 degree or perpendicular direction up along the flank of the thread, and there we were at like 0.6 millimeter. Well, actually we're at 0.45 millimeter or 17 thou RA inches at the lambda C cutoff of 80, and when they changed the lambda C cutoff from 80 to 250, which is pretty much industry standard, then we came up at around 0.58 millimeter which is like 23 thou RA. Still very, very good thread quality, very good surface finish. Something else that I was really excited to see was their profile measurement of the thread. So if we can go to the next slide. So here they were able to take a scan basically of the entire thread profile. Not all the way around, just small section like this, right? But because they have their entire machine so well calibrated, from that scan, they're able to then inspect major diameter, minor diameter, pitch diameter, included angles, and half angles, right? So I think the next slide actually shows that inspection data. So this is their screenshot of that inspection data. They inspected the entire thread for us. We were able to then use that information to make offsets for round 2. And the next slide that we have up here is their contact information. So if you need to get in touch with alicona, if you have difficult parts to measure, if you have vertical walls are very hard to measure. They're able to do it with this new unit. They're using focus variation, so it's completely non-contact measurement, right? There's nothing but light touching the part, right? So the part doesn't heat up, it doesn't get scratched, it doesn't get moved, right? I mean, when you want to talk about measuring tight tolerance stuff, you're talking about measuring in the millionths. Like, you can't even turn your lights on and off, right? It's going to affect the part, but they're able to measure that because they're not touching the part, right? So the focus variation is really great. It scans through the part, takes all the information, puts it into a 3D point cloud, and then they're able to extract from that point cloud the points that make sense based on stitching those images together. So like I said, if you want to see the unit work, contact Alicona. They'll be able to give you a full demo on your parts most likely. So that was it, right? And then we took that inspection data and we went back and we made the second part with some small changes, most of which were already incorporated there. We do have another episode coming up in short order. Yeah. We're going to be coming back to do the milling operations, which I'm very excited about. We've got some great things to show you guys with our milling cutters and our spline mill, and another great machine over at Harper. So please stay tuned, and thank you, Aaron.
Yeah, no, thank you for having me. I really had a lot of fun.
Good.
Thank you, Aaron. Yeah, and I just want to mention a couple of things. There is a full video of the visit that we had and the whole operation that you did from start to finish.
Yeah.
With that is available somewhere, maybe at the bottom of this video once it's the recorded version is available. The link will be at the bottom, and people can watch the thing from start to end, and you won't have to look at me.
But you don't get the bourbon talk.
Yeah, I know. I love the bourbon side. I will say, while you guys were all working on this, I was kind of off to the side at Harper finishing up our September issue because it went to press that day.
Okay.
Oh, wow.
So I was off making sure all the edits were in place. But this has been a great time spent. And I got to say, if we had a good solid way to you need another. Hang on a second.
For a cheer. For a cheer. Yeah. All right. Well, I do want to, before you get into that, I just want to make one comment of something that you said earlier.
Sure.
And you were talking about, I believe Will was saying, how, the machinist might have the autonomy to make, some changes and some improvements. And then you were talking about, kind of the way things are done. And I think you went into something about the engineering too. And, every place that I've worked has always had this wall between engineering and the shop floor. And the one thing that you guys kind of touched on, which I completely agree on, is that person running the machine has so much knowledge of that process that I believe is such an untapped resource, because they're running a machine for 8-10 hours a day, and they're watching things, and they're seeing how things run, and they're listening. And unfortunately, I think a lot of the people in the industry don't appreciate what that machine operator sees and knows and does, and whether it's using certain tools that you offer and how they work, or how the process works, or how there's different improvements that can be made. That and it's one thing that I try to impress upon, like, my students too. It's like, we need to work together with everybody, in that process line, and especially with the engineers. And I kind of talk from that side too. It's like, talk to that machine operator, because they know what's going on. And I go, they're going to know things that you'll never know about what's going on with the process. And they can make your life way easier. If you kind of tap into that knowledge.
Not just easier. I think the key there would be more informed, and which makes it easier. But more informed is the key there, because it's what they don't know, and they won't unless they talk to the machinist. So with that, let me just say, playing off of several things that Will was talking about. Here's to pushing the limits always.
Cheers.
To increase productivity, and always finding a more efficient way of doing the things we do today, so that tomorrow we're still in business.
Love it.
Cheers.
Cheers.
And with that, ladies and gentlemen, we are wrapped.